Good morning, everyone. A very good morning. Shall we begin the session? Today's topic is chapter number 3, that is Introduction to SQL. In the last class, we have finished with the theory, that is what is DBMS, what is the database, what is the difference between the DDL and the DML, how to create a database. That means whatever the theory that is considered over here, that is available in this one that we have studied. Now, next chapter is chapter number 3, that is the Introduction to SQL. Yes, SQL is same as the SQL, that is structured query language. And there are a number of databases, query languages in use, either commercially or either experimentally. And in this chapter, we will going to this one, that is chapter number 4 and 5, that study the basic concepts of the most widely used query language, that is SQL. And although we refer to the SQL language as a query language, it can do much as we are doing in a query language. It can also define the structure of the data, modify the data in the database, and specify the security constraints. And it is not our intention to provide a complete user's guide for SQL, rather it represents the SQL fundamental construct and the concepts, and the individual implementation of SQL may also differ in the details or may support only a subset of the full languages. Okay, alright. Let's begin with the SQL, that is a standard language, that is, yes, this is the query language that is made of the ANSI. Now, there are two parts of the SQL language. One is the DDL, one is the DML. DDL provides the commands for the integrating, or we can say the definition of the schemas, deleting the relation, modifying the relation schemas. And DML provides the ability to query the information above from the database and also to insert tuples into, delete the tuples from, and also modify the tuple. That means whatever the internal record that is done by the, or whatever the internal records updation, deletion, that is done by the DML, and whatever the modification made on the structure, that is known as the DDL. The next is the integrity, and so this or the SQL DDL includes a command for specifying the integrity constraint that the data stored in the database must satisfy, and the update that violates integrity constraints are also disallowed in this one. Then view definition. So SQL or the SQL DDL commands are also available for defining the views, and this is also used for specifying the beginning and the ending of the transaction, that is the transaction control. The next one is the embedded SQL and the dynamic SQL, that defines how the SQL statement can be embedded with the general purpose programming languages such as C, C++, and the Java. Then authorization. So this DDL commands or DDL includes the commands also for specifying the access rights to the relation and the views. And in this chapter, we present a survey of the basic DML and the DDL commands using the SQL. And in chapter number 4, that is in the next chapter, we are going to provide with the various SQL queries. That includes a join, that includes a view, that is the next part of this. So let's start with the first one, that is a DDL or the SQL DDL, SQL data definition. So the set of the relations in a database that must be specified by the system or to the system by means of the DDL. That means whenever we are going to present with the specific needs, with the specific criteria, that is run by the means of DDL, data definition language. And the SQL DDL allows the specification of not only a set of the relation but also the information about each relation, that includes schema for each relation, types of the values associated with the each data types or attributes, the integrity constraint, then the set of indices to be maintained for each relations. That is, one is the schema, one is the types of value that is associated with the each attribute, the integrity constraint, then set of the indices to be maintained for each relation. Yes, security and the authorization is one of the things that is common to each and every SQL part. That may be a DDL, that may be a DML. Then at last, there is a physical storage structure of each relation on the disk. Now, what are the various basic types? So basic types includes a char, a fixed length character string using the specific or with the user specified length n, and the full form character can be used instant. Then varchar, so this is the variable length character string with the user specified maximum length n, and the full form character varying is equivalent. That means it is equivalent with the character, it is equivalent with the scenario, it is equivalent with the database with the varchar. Yes, one is a char, one is a varchar. Next is a int, that is a finite set of the finite subset of the integer, that is machine respondent or the machine dependent, and the full form integer is equivalent. The next one is a small int, that is a small integer, machine independent subset of the integer type. The numeric, that is a fixed point number with a user specified precision, and the number consists of a p digits, that is plus a sign, and the d of the p digits are to the right of the decimal point. And therefore the numeric 31 also allows 44.5 to be stored exactly, but neither 444.5 or 0.33 can be used with a field of the same type. The next one is a real or the double precision, that is floating point and the double precision floating point numbers with the machine dependent precision. Then at last there is a float, so that is a floating point number with the precision of the at least n digits. So one is a char, one is a varchar, one is a int, small int, float, numeric, real, double precision. And each type may includes a special values known as a null values. A null value indicates the absent values that may exist but may be unknown or that may not exist at all. And in certain cases we are going to prohibit the null values from being entered, as we are going to use with the shortly. Then the char data type also stores the fixed length strings, and consider for example an attribute A of the type char10. If we store a string avi in this, so 7 spaces are appended. That means there are 7 spaces that is appended at the end. In contrast, if the attribute B were of the type varchar10, and if we store av in the attribute B, so no spaces would be added out. And when we compare the two values of the type char, they are of the different length, and there are extra spaces that are automatically added to the shorter one to make them the same size before comparison. And when we compare the char type with the varchar, one may expect the extra spaces to be added to the varchar to make the length equal. Why? Because that is a variable length, so we have to have the add the data type. We have to have the add the data, basic types in the database systems. Okay, just read out. Okay, all right. You take 2 minutes. Okay. Now let's begin with the basic. Okay. So any doubts, anyone over here? Yeah, the main difference in the varchar and the char is that one is first of all, char uses a static memory allocation and varchar uses a dynamic memory allocation. And char provides the digit. That means we are not using. We are providing the services. We are providing the digits. We are providing the specified length of the string. And in varchar, we are not specifying the length of the string. It may be going up, it may be going down, right? Now next is the basic schema definition that we'll use by creating the create table command. And the following commands create a relation department in the database. This is create table department, department name, varchar, building, varchar, budget, numeric. Why varchar? Varchar because department name may be a production, that may be a sales. Sales is 5 characters, production may be 8 or 9 characters, so this depends on the user to user. So department name, varchar, building varchar, then budget, numeric. Numeric in the sense there are also the decimal point if it is chosen up. So this is 12.2. Then primary key, department name. So this is used as a primary key, that is a department name. Now the relation created above has 3 attributes. One is the department name, that is a character string of the maximum length 20. That means we are not going beyond the 20 characters. Then building, this is also a character string of the maximum length 15, and the budget, that is also a number with the 12 digits in total and 2 of which after the decimal point. That means 2 are the decimal points and 12 is the integer value. And the create table also specify that the department name is a primary key. That means, yes, this is unique in this table. This is unique for each and every table. This is that create table R, then A1, D1, that is the data type, A2, field name, D2, AN, TN, integrity constraint, integrity constraint. where R is name of the relation and each A is the name of an attribute in the schema of the relation R. Whatever the schema that is taken out with the relation R, and DI is the domain of the attribute AI. That is, DI specifies the type of the attributes AI. And the semicolon shows at the end of the create table statement as well as at the end of the other SQL statement that is also available. That this is optional in the many SQL implementations. And SQL also supports a number of the integrity constraints. One is the primary key. That specification said that the attributes from the primary key for the relation, that is also one of the case, that may be a not null or the unique. Then foreign key, that says that the value of the specification, values of the attributes for any tuple in the relation must correspond to the values of the primary key attributes of some tuples in the relation. That may be a primary key reference department, that may be a primary key that specifies that for each and every table, each and every tuple, the department name must be satisfied, must be included in the tuple that must exist in the primary key attribute. Now, next is the not null. That is an attribute or that is a constraint that specifies that the null value is not allowed for that attribute. In other words, the constraint excludes the null value from the domain of that attribute. Not null constraint on the name attribute of the instructor relation ensures the name of the instructor cannot be a null. Now, the more details on the foreign key constraint as well as integrity constraint that the create table command may include, that is provided over here. Then SQL also prevents any update to the database that violates any integrity constraint. For example, if a newly inserted modified tuple in a relation has a null value for any attribute or primary key attribute, or if the tuple has the same value on the primary key attribute as does another tuple in the relations. SQL flags an error and prevents update. For example, when we talk about the insertion of a course tuple with the department name that does not appear in the department relation would violate the foreign key attribute, would violate the main key constraint, then prevents the insertion from the taking place. And the newly created relation is empty initially, and we can use the insert command to load the data into the relation. For example, if you wish to insert the fact that there is an instructor named Smith in the biology department with the instructor ID 10211 and a salary of the 66,000. So we write insert into instructor. Now what are the values? First of all, there is ID, then there is a name, then department, then there is a salary. So in the same manner, we are providing this one. So first of all, there is ID, then there is a name, the department name or the subject, then there is a salary. And the values are specified in the order in which the corresponding attributes are listed in the relation. That means if the ID is given at second place, so we have to provide the values at the second place. And the insert command has a number of the useful features, and that is covered over here. So we can use the delete command to delete the tuple from a relation. And the command that is used, that is a delete from student. So this command is used, delete from student. Then create table student, department name, varchar 20, building varchar. There is a building varchar, then there is a budget, that is numeric 12.2, then primary key department name. So this is a table department with the following or three fields. One field is a primary key. Then create table course. One is a course ID, then varchar, then title, varchar, department name, varchar, credits, numeric, primary key, course ID, then foreign key, references, departments. Now next is we have created two tables. In first table department there are three fields. In the second table there are four fields: course ID, title, department name, as well as the credits. Then the next table is the instructor table, that again taking out the four fields. One is the ID, one is the name, one is the department name, one is the salary. The next one is the section, that includes course ID, that includes the section ID, that includes the semester, that includes the year, that includes the building, that includes the room number, that includes the time slot ID. So that is the varchar 8, varchar 8, varchar 6, numeric, varchar. Next is the primary key, that is a course ID, section ID, semester and the year. Then foreign key, course ID, references and the course. Now, next one is creating a table teaches. Yeah, this was the next example how to create a table. One is ID, then varchar 5, then course ID, varchar 8, then section ID, varchar 8, then semester, varchar 6, then year, numeric 40. Then primary key, foreign key, foreign key. And this will delete all the tuples from the student relation, and other forms of the delete command also specifies the rows or tuples to be deleted. And the delete command is covered over here. And to remove a table from a SQL database, we use a drop table command. And drop table deletes all the information about the dropped relation from the database. This is a drop table R. That is more drastic action than the drop delete from R. Why? Because drop means everything is removed, including the structure, including the field name, everything. But when you say about the delete from R, that means that only the records are deleted out, not each and everything. Alright. So we use the alter command to add the attributes to an existing relation, and all the tuples in the relation are assigned the null as a value for the new attributes. And the form of the alter command is alter table R at AD, where R is the name of the existing relation and A is the name of the attribute to be added, D is the type of the added attribute. Then we can add or we can drop the attributes from the relation by the command alter table R drop A. Next is the basic structure of the SQL queries that I'm going to take within the next class. How to use the select, how to use the from, how to use the where. That is the main three clauses that is used with the SQL queries. Yes, select is generally used to fetch the columns from the table. Then from means the table name. And select and from are used as the same point. That means select, for example, select whatever the names, whatever the columns names. Then from table name, where is a condition or the predicate or the expression that we want to give over here. Yeah, okay. Alter is a DDL command because we are going to change the structure of the table. Then delete from R is not a DDL, it is a DML command. Why? Because we are deleting the internal records. Then drop, that is also a drop is GDL command because we are dropping the table, full table. And to remove a relation from MySQL database, we use a drop table command. And this command deletes all the information about the dropped relation from the database, whatever the student or whatever the tuple that is deleted, whatever the delete command that allows the specific tuple to be deleted, delete command is used. So one is a teaches table, one is a section table, one is the instructor table, one is a course table, one is a department table. The department, course, instructor, section and the teaches. These are the five table that is created with the multiple fields with the multiple data. Now, till now, any doubts anyone? Yeah, any doubt anyone regarding